2 over root 3. If you want to rationalize the denominator, you can. Just figure out all that. Yeah? Nice. Kayla. Hey, so you said, heck, I love these for difference of squares. Back to those. Well, when there's a 12 in front, it makes it a little what? It makes it a little tough. So you have to make sure it be like this. I don't know if you're going to like this one. Ready? That factor? Square root 12x plus 4. Square root 12x minus 4. Would you like that? It's up to you though. Could I have factored it that way?
Yeah.
I mean, you could have. Who knows? There could be a student in this class who's like, oh, I like that better. Maybe it's Kayla, but it's someone anybody. I want to point out it was a difference of squares, but since that's not perfect, I have to write whatever. Great. But look, you'll still get the same answer. X would equal negative 4 over square root. And then if you break that down, what are you getting?
That's like a 4 into 2 root 3, yep.
It's the same. It's the same number. Yeah. Cool. Oh, great job. Hey, last thing. I'm only doing one of these, okay? Don't worry, we're gonna do a bunch more of these. Like you said, we gotta do some odds. We gotta do some. But I wanted to draw a graph of an f prime, and you and I are gonna try to analyze it.
Okay.
All right. We'll have to do both of these again next class, just to make sure you got it. All right, here it is. All right. Now we're gonna have to put a word up here. Don't worry if it looks confusing to you, because this really is some abstract thought. You and I won't see any equation or anything. We're just looking at a graph, right? But if you know all the definitions, you'll be fine. If you know all the definitions, you'll be fine. Like definition of concave up. You're like, oh, that's where the slope of the graph was always increasing. Ready? And here comes f prime, okay? That's f prime. This is the x-axis, this is the y. And when you don't have to sketch f, but some of you in this class may try to help you better understand it and to answer questions, okay? You don't have to sketch f, but you may do that. That's why I put this above here. You might start doing some scratch work, okay? But this is the last thing. And you notice all my questions don't ask about f prime, but ask about what? F. But the only sketch I've given you is what?
F
F prime. Right? How about f as some points of inflection? When are you okay if I write POI?
Mm-hmm.
F is conc up. F is conc down. Let's have some fun. All right. The first thing is max and min. slope of graph was negative. Slope of graph was positive. So just the first thing I want you to think about. I want you to hold my hand. When was this graph below here? From here to here, right?
Mm-hmm.
Where else? From there to there. Now I'll just put some numbers down. How about this is x equal to like -6. Right here when x equals -3. Right here x equals 2. Right here x equals 5. Right here x equals 7. Now I'll just put an arrow and an arrow. Alright? Now, when is this graph below here?
Negative
Up
infinity
to
to
-6 and then where?
seven.
So we're saying, we know something about f. F was decreasing. F was going down. Prior to -6 and where else?
After negative 7,
After 7. Now what was the graph doing between -6 and 7 the entire time? It was what?
fluctuating.
It was going up. It was increasing. So I mean, that's really what's going on. I mean, this is down. It's like, I know this guy's like, it went down to -6, right there. But then between -6 and 7, what did the graph do? And it kept going up. It kept going up. And then when it got to 7, it started to do what again?
Going down.
And look how sloppy this is. I don't care if it's sloppy right now, I can improve it, but that's the sense of this. This graph went down, then it kept going up, going up, going up, going up, going up, and then right at 7, the slope went what? F prime is negative, that means the graph is what? Going down. Alright? But see, that's not the graph of it, but I can improve that. Does that make sense?
Mm-hmm.
But what's key is, I think we know how to identify the local max and min right away. It's when the first derivative equals 0. So for local max and mins, get your eyes right on this axis right here. Do you see any place where the first derivative equals 0?
Negative
All right, here's
3.
one. Now you might use your hands to do this. That would mean, watch me with my hands, that would mean the graph did what? It went from decreasing to increasing. Right? Slope was negative, and the slope was positive. So that's a min, isn't it?
Mm-hmm.
Does that make sense? Plus, you might do this to help you see that. So there's a local min where? Now you next 6. Now you go, what is it? We can't answer that, right? So how about we just leave the axis? I'll take that part off, I apologize. We don't know enough to put those in, right? We weren't given an equation, so I can't ask that. Where do you think there's a local max? We got 2 options. Is this the local max? Let's think about this. The graph was positive, graph was 0,
Mm-hmm.
then graph was positive again. That's not a max. Do you all agree?
Mm-hmm.
Think about this, right? Before, it's just think above the x-axis. I know it's abstract. Above the x-axis, graph was positive, graph was 0, slope was 0, and it was positive again. So that's not a max, but how about here? It was positive, then it was what? Negative. Oh yeah, there it is. What's the next value?
5.
7,
7,
right?
7, sorry.
And this is for f, right? Local max, I'll say of f. Now, we'll nail these. Everyone for increasing? Behind this? Where is it above? Go ahead and do it. From -6 all the way to what? 7. But I think it's a good idea to write it like this. How about let's go for -6 to 2, and then we'll put a union from what? 2 to 7. No, people always wonder, like, would you mark off if I just wrote -6 to 7? I'm pretty nice there. You know? But isn't it really, keep it simple, it's where it's above that x-axis?
Uh-huh.
Because the slope is what? Right, positive, it's increasing, you have told it. And where is it decreasing?
Negative infinity to negative 6, and then
And everyone was underneath this, right?
So 7
And f
to
prime is
infinity.
negative. To do this, we're just going back to the definitions. But don't worry, everyone, if you're sitting right now and you're going, you're staying silent, and you're kind of like, this stuff's a little weird. It is abstract, because we don't have any equation to deal with, do we? We're just going based on conceptual ideas, right? This is conceptual understanding. It's decreasing where else?
7 to infinity.
Now, points of inflection, this is my favorite. Everyone, would you just look for the hills? Josephine, points of inflection. And this F prime graph, would you just look for the hills?
Yep.
You go, why? Because that's where the concavity would change. That's where second derivative would change. If this is F prime, then where does F double prime change? Wherever I see a hill.
Negative.
Oh, there's a hill, boop. Point of F. I love these. Where else is a hill?
Two.
Oh, right there, point of F. I love these. It's so easy to find points of inflection on an F prime graph. It's where it's where second derivative changes. Okay, if this is first derivative, just see we're going up to down. Or down to up. Where else is there a point of F?
At 5,
So how many points of inflection are there?
3.
At x equal to
Negative 3,
negative 3, comma,
2,
2,
5.
and comma 5.
5.
And now we can do concave up and concave down. Because where's the concave up? In between these.
Yeah.
You know? Concave up, remember second derivative is what? Positive. Well, this is a first derivative. So just look to see where the slope was from. Concave up. Concave down. Concave up.
Ah,
So where's the concave up?
so
From
negative
negative infinity to the
3.
negative 3. I'll put a union anywhere else. 2 to 5. And where is it? Concave down. That was just the opposite. In between these points of inflection, it went concave down from. Now, everyone, trust me, I know this topic. Years and years and years of teaching calculus. I can have the student who hates algebra, they love this stuff, right? Or vice versa. The student is just awesome in algebra, and they say, I don't like this stuff. So I understand it, so I'll make sure next class we do another one of these, okay? It's all going back to definitions, but there's ways you can figure out, you can know what to look for. Like my favorite's the points of inflection on F prime. It's just gonna be where what? It goes like that, it goes like that, right? And great job. Have a great weekend. I'll make sure our next class, we'll do some more of those then, a little more complicated stuff. Have a great weekend.
So,